Now this is a heart which we used. Here you see the valves. These are mechanical valves.
In 1969, Dr. Denton Cooley spoke about a heart transplant he'd completed.
This more or less conforms to the shape of the human heart.
And since then, the need for hearts and other man-made organs has only grown.
The organ donor shortage is a public health crisis now, and that's been considered so by the Hospital Association because there are just not enough organs to go around. We're living longer, and the longer we live, the more organs tend to fail. The number of patients on the transplant wait list keeps growing year after year, yet the number of patients actually receiving transplants, those numbers have remained relatively flat. And that is just because there are just not enough organs to go around.
But what if, instead of waiting for your perfect organ, if it's even out there, then getting to the hospital in time, undergoing intensive surgery, and spending the rest of your life taking medicines so your body doesn't reject it, what if instead of all that, there was this? It's a proprietary 3D bioprinter at the Wake Forest Institute for Regenerative Medicine in North Carolina. To catch you up, scientists here have been hand-building organs for patients for years. That means they use a patient's tissue and stem cells to create a new organ. Instead of getting a transplant from someone else, their new organ is a cellular match to their old one. There are limitations. Building organs by hand isn't just time-consuming and open to human error. The technology can't produce complex organs like a heart, or even get the organs that can be made to everyone who needs them. But now, these scientists believe they've cracked the code for teaching a 3D printer to build organs for them.
You can see that as we go through each layer, the pattern changes just a little bit. And then when you put it all together, you've got a 3D printed ear. And the way that this works is we'll take a MRI or CT image, some sort of medical imaging, and then we convert that into a 3D computer file.
While creating an ear with a printer is very cool, it's minor compared to what's next: printing livers and hearts and kidneys. Kidneys make up some 80% of the organs needed for patients on the transplant list.
So we've been doing a lot of work in solid organs like the kidney to try to get technologies into patients. The sample that you're seeing with the printed ear is just a representation of the strategy that we use for basically all the organs that we're engineering. Using the patient's own cells, printing the structure with a mold, and then allowing that to mature and then being planted back into the patient's own body.
Of course, livers and kidneys are much more complex than an ear. I spoke with Dr. Anthony Atala about what it would take to get there, 3D printing complex organs on demand. Livers and hearts and kidneys, they're thicker than an ear and have microscopic pathways running through them that carry things like blood vessels. Dr. Atala is still a practicing surgeon, but his research at the Wake Forest lab has made him an icon in the regenerative medicine space.
So right now we have several structures that have already been implanted into patients. Engineered skin, urethras, blood vessels, bladders, vaginal organs. They've already been implanted into patients. The nice thing about the 3D printer is that it allows us to take the technologies we could implant by hand, and it can automate the process, but also it gives us reproducibility because we can produce the same organ the same way every time. It gives us reliability, and it also allows us to lower the cost. So we can get these technologies to more and more patients over time.
The first organ Dr. Atala implanted into a patient was a lab-produced bladder. It went into Luke Masala. He was born with spina bifida, a birth defect that impacts the development of the spine. By the time he was 4, he was having trouble emptying his bladder and needed a series of surgeries on his spinal cord.
By the time I was 10, the main concern became I kept getting kidney infections. I was having bladder pain, and they found out that I was in full kidney failure by the time I was 10. and it was not being caused by the kidneys itself. It was being caused by the bladder, which was sending fluid back up into my kidneys and causing the kidney failure.
So he needed a new bladder. And at the time, the concept of regenerating Luke's bladder was totally experimental.
So in 2001, in June, I had the first step of the procedure, which was just really a biopsy of my bladder. So it was a smaller surgery. And then over the next 2 months, they used that piece of bladder to grow a new one in a bioreactor in a lab. And then August 2001 was the larger portion of the surgery where they put this new bladder back in.
Remember, he was 10 at the time. Now 30, the procedure worked, and Luke went on to captain his high school wrestling team and go to college, things that would have been difficult if not impossible before the new bladder. While Luke's was handmade in a lab, that process has inspired an entire industry dedicated to 3D printed organs. The original bioprinter Dr. Atala used in proving that 3D organ and tissue printing could work is now at the National Museum of Health and Medicine. It printed skin for burn victims, and the most mind-blowing part is it's literally a consumer-grade Hewlett-Packard inkjet printer. But instead of ink, the cartridges were filled with cellular matrix material that could be printed in a series of layers. The technology has definitely evolved since then, and it's just the beginning. A company called TechShot had an idea. If the printer was small enough and could get to space, would microgravity make it easier to print an organ?
So this spent about 6 months in space. We ran about 5 or 6 different series of prints.
Dr. Gene Boland's space-traveled bioprinter is back on Earth now for a tune-up and the addition of some new technology. While in space, operators at TechShot's headquarters provided instructions to astronauts on the International Space Station about how to operate the printer, execute experiments, and document results.
So we have 4 different print heads, so we can print with 4 different materials at the same time. This gives us a maximum versatility in the bioprinting process. So we can print like vascular tissue, supportive tissue, muscle tissue, nerve tissue. So really the whole idea is to recapitulate what you would need for organ printing and for adult tissue printing. Even though cells are very small, they still respond to gravity. So on Earth, those will settle out through the gel. In space, they'll stay where you put them. And if they stay where you put them, then you can put them in a manner that vessels can regrow faster.
With microgravity on their side, Dr. Boland says their first printing attempt was successful in that the printer worked. But what it produced didn't survive re-entry.
SpaceX has a nice rocket, but it's not the most gentle rocket. And so we brought back a really cool pile of goo. It lost its structure on the return trip. Our goal is to get a fully formed heart, but think of it more as a neonatal heart. So it'll be sized appropriate for your body, but because it was in microgravity and because of the way that we're conditioning it, it probably can't step in instantly and pump the 5 to 10 liters a minute that your heart does. But I think it's something that we can get mature enough that it becomes functional, and then the ability for it to continue to grow, continue to mature and remodel in your body is what's going to separate this from all the other transplant technologies.
So what does the FDA think of this emerging biotech? After all, they'll be responsible for regulating it. The agency declined to interview for this story, but a spokesperson told me, printing constructs containing living cells intended for implantation in patients are still in the research and development phase. And there are currently no FDA-approved or cleared 3D printing products, such as 3D printed tissue or organs.
Scientists and investors and public health officials in this space want to know what trials they have to design, what the pathway is to regulatory approval, so that they can develop the products appropriately, and that they have a pathway to commercial utilization and commercial success, which would be ultimately incredibly good for patients.
Dan Troy, a former chief counsel for the FDA who now works for a medical research company and sits on the board of another, recently wrote an op-ed highlighting how the lack of a regulatory structure can strain scientific progress. In 2016 and 2017, the FDA released draft guidance, but hasn't finalized anything. An agency spokesperson said there are multiple divisions inside the FDA that regulate different parts of the printing ecosystem.
The FDA's authorities are tailored to or anticipate, let's take the typical small molecule or a vaccine, the same product produced over and over and over and over again. But 3D printed organs would be, in at least one formulation, bespoke. They would be your cells. And so FDA has to figure out a way to be able to compare really the process for making this bioprinted organ from one person's cells and another person's cells and another person's cells. You can't compare all three of those, right? You have to actually spell out how the process will be regulated. And until that kind of regulatory clarity comes, it's going to be somewhat of a hindrance.
You know, we're constantly battling that, right? We're constantly battling the urgency of the need and the need for scientific rigor that needs to be there to be sure that these technologies are safe. Because the last thing you want to do is take a technology to help a patient that's going to hurt them.
So when will you be able to get a 3D printed organ on demand? Dr. Atala isn't quite ready to offer up a timeline. His patients, though, understand the urgency.
I have a different perspective because obviously I was in that boat, but I think it's something that like the average person or healthy person doesn't really think about because they've never gone through it.